is going to ask you to classify triangles by their angle measure and their side lengths. And the only thing I want to warn you about is I'm going to test you on the test those concepts separately. So I'm going to ask you to classify them by their angle measures, and then maybe on a different problem I'm going to say classify it by the side lengths. You need to make sure that you understand what are the names for angle measures and then what are the names for side lengths, and pay close attention to the directions, okay? You're also going to classify those triangles, which is what I'm talking about, so moving on. All of these vocabulary words are actually in separate slides in your notes, okay? So we start with just a little bit of basic review of notation. On the homework, they may ask you things like, what are the vertices of the triangle? Well, vertices are points. So don't forget that when you name a point, you just name it with a capital letter. So my vertices of my triangle are point A, point B, and point C. They might also ask you on the homework to list the sides of the triangle. The sides of the triangle are line segments. So you're naming the segments, AB, BC, and AC. Okay? And that's pretty basic, but some of us are still having trouble with how to name things. So be real careful with that. All right, so now we're ready to classify, and what you'll notice is it's kind of dark in this red box. On yours, it's really dark gray, so it's kind of hard to see. But this says by angle measures. So the first set of notes, first page, is classifying triangles by their angle measures. So if we're going to classify it as an acute triangle, then it has to have 3 acute angles. And the definition on your vocab test will be, what is an acute triangle? A triangle with 3 acute angles. So all of these are vocabulary. Another way to classify a triangle by angle measures is if all 3 angles are congruent. Then it is equiangular. You will need to be able to spell that word. And it is not equal angular, it's equiangular. No L. This is the one that some students get confused on, because look at all 3 angles. If they're all 3 congruent, it's equiangular. But we just said that if it was acute, it has 3 acute angles. What does it mean to be acute? Less than 90, so that means they're all going to be less than 90 degrees. So if it's equiangular, do you know what the measure of each of those angles would have to be? 60. So are they all acute? Yes. So it is acute, but if I ask you to classify the triangle, I'm looking for the most precise name. So this is an acute triangle, but I want it to be most precise, so we would say equiangular. Okay? All right, next one is if it's a right triangle. A right triangle is going to have only one right angle, unless we're on a sphere. There are two types of geometry. There's plane geometry, which doesn't mean like plane in the sky, but it means you're plane, like a flat surface. And that's what we learn in here. We learn plane geometry. 2-dimensional, on a plane, this is the geometry behind it. Then there's kind of what I would call real world geometry, in that it's spherical. And if you think about what we live on, the Earth, we live on a sphere. But because it's so huge, most of what we do, it tends to be more like a flat surface in our small little world, right? We're not looking at the great big sphere. But on a sphere, a triangle does not have to have a sum of 180. If I draw a triangle on a sphere, it's going to be greater than 180. So a right triangle is not necessarily just a triangle with one right angle if we're thinking about spherical geometry. Okay, but we're not going to talk about that. That'll come later in your math career if you choose to take it, go on in college. So we're going to only focus on on plane geometry, and that's one right angle makes a right triangle. Obtuse is if it has one obtuse angle, and what does it mean to be obtuse? Greater than 90. So there's 4 ways to classify triangles by angle measures. It can be acute, equiangular, right, or obtuse. Acute, equiangular, right, or obtuse. Questions on that? Okay, let's look at some examples. Classify triangle BDC by its angle measures. And what you'll notice is they don't give you just a simple little triangle. They give you a crazy picture, and you got to try to find things. So B to D to C, we're looking at this triangle. What would it be? Obtuse. It is obtuse because which angle is obtuse? Angle B. DBC, this angle here. Questions? Okay, next one. What is ABD? Do we know all three angles in the picture? No, we know one of them's 80 and one of them's 20. How are we going to know for sure that this is acute and not right or obtuse? Okay, because we have a linear pair here. And if this angle is 100, then what does angle ABD have to be? 80, because they're supplementary. That's the linear pair theorem. Two angles that form a straight line are supplementary. So if this one's 80 and this one's 80 and this one's 20, it is an acute triangle. By angle measures. Okay, by angle measures. The next 3 slides are going to be classifying triangles by side lengths. So 3 ways you can classify by side lengths are, you can have a triangle that has all 3 sides congruent. If it does, it is equilateral. Make sure you can spell that. If it only has 2 sides congruent, what's it going to be? Isosceles. That's the next one. In middle school, you probably learned it as isosceles has 2 congruent sides. In geometry, I'm going to emphasize it actually is at least 2 congruent sides. Here's where that would be important. I give you a question that says, an equilateral triangle is always, sometimes, or never an isosceles triangle. I'll say it again. An equilateral triangle is always, sometimes, or never an isosceles triangle. Does an equilateral triangle always have at least 2 congruent sides? Yes, so the answer would be always. If we just said it has 2 congruent sides, it would still be always, I guess. But I think it just is important you get that if it has 2, it's isosceles. If it has 3, it could still be considered isosceles, but it's more precisely equilateral. What if I flip that? An isosceles triangle is always, sometimes, or never equilateral. Sometimes, because it has 2. If it had a third, then it would be equilateral. Good. Okay. So it can be equilateral, it can be isosceles, or it can be scalene. And scalene means that it has no congruent sides. So 4 ways to classify by angles, 3 ways to classify by sides. Some of the problems on the homework will say to do both, classify it by sides and angles, but sometimes it'll just ask for one or the other. Very important. We are never, ever, ever going to assume anything about our pictures. Ever. Okay? Never assume. Ever. Okay? Never. You are only going to go off the markings, and that's going to go from here on out all throughout the course. Classify. Side lengths. EHF. What is it? Isosceles. It has 2 markings saying that these 2 are congruent. Therefore, we know this one is 10 also. 10, 10, and 12 would be isosceles. Next one. Now we're not just classifying, we're trying to apply it to some problems, solving for their lengths. What kind of triangle do I have in this picture? Isosceles. It's got 1 marking and 1 marking, which means those 2 sides are congruent. So if I want to find the value of the side lengths, the first thing I'm going to have to do then is find the value of x. So what do I need to do? Set them equal to each other. Which ones am I setting equal? JK and KL, good. So 4x minus 10.7 should equal 2x plus 6.3. Solve it. What do I do? Subtract 2x. So 2x minus 10.7 equals 6.3. Now what? Add 10.7. And 2x is 17. And so x is 8.5. Half of 17 is 8.5. So if x is 8.5, we have to plug it back in to find the side lengths. Let's start with j to k. 4 times 8.5 minus 10.7. What is 4 times 8.5? To be 34, the easiest way would be to say we know 2 times 8.5 is 17, and 17 plus 17 is 34. Or you could go over here and do the math. 20, 32, 34, one number after the decimal. So it is 34 minus 10.7. It's 34 minus 10.7. 23.3. Do I need to plug it back in for KL? No, because if JK is 23.3, we know that KL is also 23.3. We might want to, if we're taking a test and we have time, because then we can make sure we didn't make a mathematical error somewhere, because they should be equal. But if we don't have time, we don't have to plug it in. Now we just need JL. 5x plus 2. What is 5 times 8.5? Should be what? 42.5, because 5 times 8 is already 40, right? So it's going to be bigger than 40. 42.5 plus 2 is 44.5. And it just said find all the side lengths of the triangle, so now we know them. Questions? Is this making sense? Okay. Go ahead and look at the next one and figure out what the side lengths of that equilateral triangle are. Find the side lengths. Make sure you're finding the actual side lengths of the triangle, not just the value of y. Okay, I think a lot of people have gotten the value of y and then plugging it in, so let's check. What did you do, Caroline, to solve for y? 3y minus 4 equal to 2y plus 3. What did you get for y? 7. Did anybody use a different equation than this one? Nobody did? Hannah, what did you do? Okay. Hannah said this side equal to this side. Is that okay? because they're all equal. Doesn't matter which two you pick, any two should have given you y equals 7. Does anybody need me to solve that and show how we got 7? Okay, plug it back in. What did you get for the lengths of the sides? 17. Did you have to plug it into all of them? No. Could you? Sure, just to double check and make sure you've done it correctly. All right, go ahead and look at the next 2 word problems and try to work those 2 before lunch, and we'll check them when we get back. So pull that out. 4-3. Okay, big idea in 4-3 is we are going to talk about interior angles versus exterior angles, and then we are going to learn really 4 theorems, and that's about it. And you're just going to apply them, and the theorems aren't hard. What's going to be hard is remembering the name of the theorem and what it says, because you will be using these theorems in proofs later. So it's really important that you get the name and what it says down today as we go through it. The first theorem we're going to talk about is something you should already know. And that is triangle sum theorem. What do all of the angles in any triangle always add to equal? 180. You should have learned that before you ever got to high school. It is called the triangle sum theorem. That's the only thing that maybe you didn't learn, was what was the name of the theorem. And it simply says that if you add all the angles in a triangle, they'll always add to be 180. Okay, and so we're going to use that here in a little bit. Keep that in mind. We're going to be working on proofs. We've talked about how this chapter is going to include proofs. So one thing that's going to be new to our standard format of doing a proof is that we might want to add a line in our picture. They may give us a picture, and from what's given, we can't go anywhere. We're stuck. And so what we can do is we can add what's called an auxiliary line. An auxiliary line is a line that is added to a figure in order to aid in a proof. And I'll show you an example of what that would look like. Excuse me. If I just had this triangle ABC, just this blue triangle, then, they asked me to prove something. I may be stuck. I may not know what to do from here. All I have are these 3 angles. What I could do is add in this line L. In my proof, I would put number 2. Draw line L, and my reason would be definition of auxiliary line. So in a proof, you can draw a line in your picture, and your reason is just the definition of an auxiliary line. And then what that does when I draw in line L is it actually creates 2 different angles that were not originally in my picture. It creates angles 4 and angles 5. And so then I could use 4 and 5 maybe to get to what I'm trying to prove. We will have a problem, at least one, on our homework where you might have to draw in an auxiliary line. But for the most of them, they're going to be just prove what's given, okay? All right, so here's an example that goes back to our triangle sum theorem. After an accident, the positions of cars are measured by law enforcement to investigate the collision. Use the diagram drawn from the information collected to find the measure of angle X, Y, Z. What is angle X, Y, Z? What is it? 72? Close, but I don't think it's 72. 78. Because 62 and 40 is what? 102. And what do we know that all 3 angles in the triangle have to be? 180. So 180 minus 102 is 78 degrees. Triangle sum. All of the angles in the triangle will add to be 180 degrees. Look at the next one and go ahead and find YWZ. Okay, on yours, they actually drew the angle measure in or gave you the angle measure. If this were my problem and they did not tell me what this angle right here was, how would I find that? And what am I using to get that? Linear pair theorem. The linear pair theorem says that two angles that form a straight line form a linear pair that are supplementary. Okay? So these two angles would be supplementary because they're a linear pair. So 180 minus 162, they told you was 118, but they didn't need to. You should have been able to find that that was 118, and I expect you to be able to on the homework. 118 degrees is this angle. This one is 12. So what is YWZ? How did you get 42? Okay, and then? So 180 minus 118 would be 62. Okay, but that's not my answer. So Jonathan, be careful. This angle plus this angle does not add to be 180. Okay, so what should I do? I don't just do 180 minus 118. That's not the measure of this angle. Okay, 118 plus 12 is what? This is what? 130. So 180 minus 130 is what? 50 degrees. So the measure of that angle is 50 degrees. Questions? Okay, what theorem did I just use there? Triangle sum theorem. Get the name in your head. Question back here? Caleb? Yes, so if they'd asked me for WYZ, but they asked for YWZ, which is this angle down here. But yes, Caleb, if they had said WYZ, then my answer would be that it's a 90-degree triangle. Okay? Very good. Yeah, no, it just wanted the measure of angle YWZ. All right. Go over to the back page and see if you can figure out the measure of angle MJK. And if you're having trouble seeing it on your paper, it might help to look up here on the board. Again, your picture may be kind of hard to tell, but if you look on the board, you'll notice there are some red markings. Look at those red markings and see if that helps you. Some people are already done and moving ahead. Some are still working. All right, let's talk about it real quick. First of all, make sure you're finding the right angle you're looking for, MJK. So M to J to K. Most of you were doing pretty good there and realizing that that's the one you're looking for. What was hard to see in your picture is a little easier up here because it's in color, that these two little marks are congruent. So at this point, I don't have enough information in the blue to find the blue angle, but if I could figure out the red angle, then I could find the blue angle. So start by trying to find the red angle by using the red triangle here. What would I need to do? Add 88 plus 48, and what do you get? 136, and then do what with that? Subtract it from 180, and what do you get? 44, and that's the measure of this angle, as well as the one it's congruent to over here in the blue triangle. So now what do I do? Okay, so 104 plus 44 is 148, and now we're going to subtract that from 180. Oh, why am I drawing my line? And what do I get? 32 what? Degrees. Questions? What theorem did we use twice there? Triangle sum theorem. The more you can say it and get that in your mind, the more you'll memorize it. Okay, next concept is we're going to be talking about corollaries. So like we don't have enough information already. We've got properties, we've got postulates, we've got theorems, we've got definitions, and now we get to have corollaries. The only thing that a corollary is that's different is that a corollary is simply a theorem whose proof would follow directly from another theorem. Our old book said it is a proof that is easily proven. And my students used to say, there's not such a thing. There's not a proof that's easily proven, Miss Ashley. So I like this one a little bit better because it doesn't say it's easily proven. It just says it directly follows. So make sure you got this clear in your mind. A postulate is not proven true. It's accepted as true without proof. A theorem can be proven true, and a corollary is a theorem that just comes directly from the previous theorem. So it's something that is a quick proof from what was given earlier. And so here's two corollaries that are going to follow from the triangle sum theorem that we've been using. The first corollary says, if you have a right triangle, and we know that all three angles have to add to be 180, if one of them is 90, then what would the sum of the other two have to be? 90. So this corollary comes right from the triangle sum theorem, says if you have a right triangle, then angle D and angle E are going to have to add to be 90 degrees. And what do we say when two angles add to be 90? What are they called? Complementary. So D and E will be complementary. It's a shortcut. If they tell you that you have a right triangle and one of the angles is 20 degrees, you don't have to do 90 plus 20 is 110 and subtract it from 180. You can just simply say 90 minus 20 is 70, because two of them are going to have to add to be 90. Is that okay? And then I think it was Luke, I may be wrong, but somebody back there earlier said, when I asked you if it's equiangular, do you know what the angles are? And somebody said 60 degrees, and that's this corollary. So whoever that was. If you have a triangle that is equiangular, and all three of them have to add to be 180, then you're basically saying x plus x plus x is 180, or 3x is equal to 180. So when you divide by 3, x has to be 60. And so it comes right from that triangle sum theorem. So from here on out, every time you see an equiangular triangle, you should automatically know if it's equiangular, every angle is 60. And you should be able to work it from there. We won't really necessarily, you might use them in a proof, but not as often. If you do, they don't have a name. You'll just have to write out an equiangular triangle. In an equiangular triangle, all angles are 60 degrees. Or if it's a right triangle, then the other two angles are complementary. So you just have to state it in your own words. Okay? All right. This one. One of the acute angles in a right triangle measures 2x. What is the measure of the other acute angle? A lot of students who always struggle with this one because they've got variables. So let's stop for a second and let's say one of the acute angles in the right triangle measures 30 degrees. What is the other acute angle? What is it? Nope. One of the acute angles in a right triangle measures 30 degrees. What's the other one? 60, because 90 minus 30 is 60. So the other acute angle would be 60 degrees. Is everybody with me? Because the other two angles are complementary if you have a right triangle. So in this one, if we say that it's 2x, what is the other angle going to have to be? Where are you getting 4x from? How do we know it's twice as much? Okay, but that's just in this example. What if this was 10? What would this angle be? 80. Now it's 8 times as much. So we don't know that it's twice as much or 8 times as much. We just know that they're complementary. Say it again, Jonathan. It's as simple as that. It doesn't ask you to find out the actual numerical value. It just simply says, what's the measure of the other angle? They told you one angle was 2x. They didn't give it to you as a number. They gave it to you as an expression. So the other angle would just be 90 minus 2x. Sometimes you can go ahead and find x, but in this case, we wouldn't be able to know what it is. We would just know that if one of them's 2x, the other one has to be 90 minus that. I know. And if you ever have a question on the test and you're not sure, am I supposed to get a number value here, or are you just looking for an expression, you can ask me. That's a question I would answer for you. Okay? Caleb? Not necessarily. They would both be obtuse triangles or both be right triangles, but, and I can show you real quick, Caleb. Is it going to fall? Nope, it almost did. And I'll break these out when we're actually doing that lesson, but for example, so both of these could be right triangles, but they're not going to be the same size because I'm going to have a different length of my hypotenuse that's going to connect, and the yellow side is shorter than the blue side, and the orange side is shorter than the green side. Does that make sense? So they may both be obtuse, but then depending on the lengths of the legs will determine whether or not the actual triangles are the same size. Okay? All right. Here we go. Here's one with some fractions, since you guys love fractions. What's the measure of the other acute angle? What would the answer be? What did you say, Jonathan? Close? 41 and 3/5. We know that if it's a right triangle, once again, the corollary says that the other two have to be complementary. So save yourself time and just do 90 minus 48 and 2/5. For those of you struggling with proficiency, let me show you a shortcut here. You could change it to decimals, but if we're trying to work with fractions, I can borrow from the 9, make that an 8, which makes this 10. Borrow from the 10, make that a 9, and I have a whole number here. Since I've divided these into 5s, what could I call my whole in terms of 5s? 5 out of 5, or 5/5, right? You agree 5/5 is 1? And then I can subtract. What is 5/5 minus 2/5? 3/5. 9 minus 8 is 1, and 8 minus 4 is 4, and now I have 41 and 3/5 degrees. Okay? All right, let's move on to the next kinds of theorems. So we've learned one theorem so far, and that was triangle sum, and then a couple corollaries. If it's equiangular, they're all 60, and if it's a right triangle, the other two angles have to be complementary. The next theorems are going to deal with interior angles versus exterior angles in a triangle. And you are very used to triangles and interior angles. That's what we just talked about. Sum of all of the interior angles is going to be 180. Exterior angle theorem, or the exterior angle, is going to talk about if I extend one of those sides out, then now I'm going to have this angle formed that's outside my triangle. And that's called an exterior angle. Interior are the ones that are inside, and exterior is one that's outside. And I could extend any side in one direction and create an angle that's outside my triangle. So if you look at this one, the interior is simply the set of all points inside the figure, and the exterior is the set of all points outside the figure. That's pretty common sense. But then when we go to interior and exterior angles, that's the part that's kind of new. And still, I don't think it's hard. It's just understanding what it means. Interior is formed by two sides of the triangle. So 1, 2, and 3 would all be interior angles. An interior angle is formed by two sides of your triangle versus an exterior angle. An exterior angle is formed by one side of the triangle and an extension of an adjacent side. So I have to extend out one of these sides and connect it to one side of the triangle. And angle 4 then would be an example of an exterior angle. Did I go too fast there? Slow down. One thing I want to point out with exterior angles is make sure you understand that there's only one at every vertex. It's not extending out both sides. So I don't extend this way and extend this way and then create 3 new angles. It's one side and an extension of the other side. So you only extend in one direction, okay? I can either extend this way or I can extend this way. This becomes an exterior angle. And I can have an exterior angle, one at every vertex. Okay? Remote interior. That's going to lead us to the next theorem, and it's going to use the word remote interior angle. So it's important you understand what remote interior. When you think of the word remote, other than a TV remote, what does remote mean? Far away. So when we say remote interior angle, what we mean is an interior angle that is not adjacent to the exterior angle, or the angles that are the farthest away from the one I'm looking at. So a remote interior, if I'm looking at angle 4 here as my exterior angle, which angle is touching angle 4? Is right next to it. Number 3, it's adjacent. So 3 is not far away. Which angles are further away than angle 3? 1 and 2. So 1 and 2 would be considered the remote interior angles. They're the furthest away. So remote interior angle is an angle that is not adjacent to your exterior angle. And there should be 2 remote interior angles every time. If I look up here and extend this side out at 2, so that now I'm looking at this angle 5, what would be the 2 remote interior angles? If I'm looking at angle 5, 1 and 3. Remote interior, Jonathan, be careful, 4 is an exterior. Which leads us to our next theorem, exterior angle theorem. What it says is, and let's see if this makes sense, the measures of an exterior angle, like angle 4, will be equal to the sum of the measures of the remote interior angles. So angle 4 should be equal to the sum of 1 plus 2. Now think about why that's true. What do we know about angle 1, 2, and 3? They had to be 180. What do we know about angle 3 and 4? They had to be 180, right? So if I think about this kind of in a proof, measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals 180. Measure of angle 3 plus the measure of angle 4 equals 180. Now stop. What theorem am I using for the first equation? Triangle sum theorem. 1, 2, and 3 are the angles in the triangle, and I'm saying that they add to be 180. So triangle sum theorem says 1 plus 2 plus 3 is 180. What theorem did Luke use to say that 3 plus 4 is equal to 180? Linear pair theorem. Are you guys with me? The more you practice those names, the better you're going to do on proofs. So now look at what we have. What allows me to combine these two equations to say measure of angle 1 plus measure of angle 2 plus measure of angle 3 is now equal to the measure of angle 3 plus the measure of angle 4. Transitive, good. If I have the exact same thing on one side, I can combine them. So this is now equal to this. What could I do from here? Subtract what? So I'm using the subtraction property of equality, and I can cancel out those measure of angle 3's. And I am left with measure of angle 1 plus measure of angle 2 equals measure of angle 4. My exterior angle 4 should be equal to the sum of the two remote interior angles. And that's what they mean by this is kind of like a corollary because it follows quickly from the triangle sum theorem. Okay? Does everybody follow that okay? Exterior angle, this one's going to be huge. You're going to use it a lot, and then when we don't use it for a lesson or two, it's going to pop back up on another lesson. So you really need to make sure that you get it. An exterior angle should always be equal to the sum of the two angles not adjacent to it. Excuse me. Let's look at the next one. Now we're going to apply it to a picture. Next two pictures, both of them. They want me to find the measure of angle B. What equation could I write down to find the measure of angle B? Exactly. My exterior angle, BCD, 5x minus 60, should be equal to the sum of the two remote interior angles, 15 plus 2x plus 3. Exterior angle theorem. Now let's solve it. Combine like terms. What do I get on the right? (15 plus 3 is, thank you, 18 plus 2x, 5x minus 60. Now what do I do to solve? Subtract 2x. So 3x minus 60 equals 18. Good. Add 60. So 3x equals 78. Divide by 3. What's x? Everybody agrees 26? Okay. Is x what I'm looking for, though? No, what does it want? Measure angle B. So measure of angle B is equal to 2 times x plus 3, or 2 times 26 plus 3. What's 2 times 26? What's 52 plus 3? And Andrea, what do I need to remember to put? Degrees. Very good. Questions? What theorem did I just use? Exterior angle theorem. Exterior angle theorem. Go to the next one. And let's just set it up. I'm not going to go through and solve it to save time. I'm looking for let's just go through and solve it. I'm looking for A, C, D. What would be my equation? (2z plus 1 plus 90 equals 6z minus 9. Can I warn you of a mistake that I always end up seeing somebody do? I always have somebody who says, I don't know this angle right here. I'm going to call it z. Because I've got z's in my picture, I'm just going to call it z. Or maybe I heard x. Maybe the problem was actually 2x and 6x, and so they go x. I don't know what it is. Why can't I call that x if this is 2x plus 1? Okay. X is already defined to be some number. Even though we don't know what it is, it's already got a value assigned to it. I don't know that it's the same value for this angle. Don't use a variable that's already been defined. Okay? All right. So can we just skip from here? Are you good? Do I need to go through and solve it? Yes? Okay, let's solve it. Subtract 2z. And we have 1 plus 90. I probably should have combined like terms first. What's 6z minus 2z? 4z minus 9. What's 1 plus 90? 91. 91 equals 4z minus 9. Add 9. What's 91 plus 9? 100. So 100 equals 4z. Z is 25. The question was, what's A, C, D? Z minus 9. 6 times 25 is? Good. 150 minus 9 is? 141 what? Degrees. What if they asked me for the one that was adjacent to it, which is ACB? Subtract it from 180. What theorem are you using? Linear pair theorem. Trying to help you process those theorems that we're going to be using over and over again. All right. Third angles theorem is our last theorem for today. Third angles theorem is exactly what it says. Third angles. It says that if two angles of one triangle are congruent to two angles of another triangle, so two angles of one triangle are congruent to two angles of another triangle, since the sum has to be 180, if two of them are already the same and the other two are already the same, does it make sense that the third angles would have to be the same? Because if this one's 50 and this one's, let's say, 60, together that's 110, and 110 from 180 is 70. So over here, if these are congruent, 50 and 60, then this one has to be 70. Third angles theorem says that it has to be congruent. Yes, and it will. We will use all of these terms we've been talking about to eventually prove triangles congruent. Yes. Third angles is one of them that we use a lot, though. Good. Third angles theorem. So two congruent, the third angles have to be congruent. And let me go ahead and say, there is no third sides theorem. When we get to proving triangles congruent, I always have somebody who wants to say, this side's congruent to this side by the third sides theorem. We don't have one. It doesn't exist. Okay? We have a third angles, but we don't have a third sides. All right, so let's apply it to a couple pictures and we'll be done. Angle K and angle J are what we are looking for. What do we know about K and J according to this picture? They're congruent. Make sure that you can handle the fact that sometimes your triangles are overlapping, and that doesn't confuse you. Big triangle has one congruent to the next triangle, let me use a different color, which also has one mark. So these are congruent, and then we have the 2 marks and the 2 marks. So the third angles have to be congruent. So what do I write down? Good. 4y squared equals 6y squared minus 40. Okay, heads up. What do we call an equation that has a square in it? Say it again. Nope, that's a square root. What do we call it if it's got a square? Quadratic. Do you remember solving quadratic equations in algebra? Factoring, quadratic formula. It's coming. You're going to be expected to be able to solve quadratic equations in here. You learned it in Algebra 1. We'll review it in Bell Work, but you're going to have to be able to do it, okay? In Bell Work, we'll review it quickly. This one, however, is not one that's difficult because it only has a y squared. It doesn't have a y. Remember, factoring and quadratic formula were used when you had an x squared and an x, or a y squared and a y, or a z squared and a z. Here, I just have y squared, so it'll be easier. What do I do? By subtracting what? 4y squared. Yes, 4y squared from both sides. So this gives me what on the left? 0 equals? Good. So now I have 40 equals 2y squared. Divide by 2 first. So 20 now equals y squared. Take the square root. Now, y equals the square root of 20. Stop there for a second. If they said, give me the answer for y, eventually that would not be correct. Did you in Algebra 1 learn how to simplify a radical? Okay. You should have learned how to simplify. What I found out from my first hour class is that that's about all you learned to do. A lot of you didn't learn to add radicals or subtract radicals or multiply radicals or divide radicals. So luckily, first hour figured that out, and we had to go back and learn that, so that now when we get to that chapter for you guys, I will do it ahead of time, okay? But you should have learned how to simplify them. So what are the factors of 20? Okay, I heard two different answers. I'll go with 2 and 10. 5 and 4 would have been fine. What are the factors of 10? 2 and 5. What do I look for? Okay, so you have to have a buddy to go out of the house, or you're looking for a pair. If I have a pair of 2s, it goes out front. 5 doesn't have a buddy, so he stays in the house. 2 square roots of 5. Anybody not ever seen that before? Okay, good. This is what I expect your answer to be if you're giving me the answer for y. But they didn't ask for y, right? They said find the measure of angle K and J. So you could leave your answer as the square root of 20 to substitute it in, or you can simplify it and then substitute it. Let's review both ways, because this is where I sometimes have students who have trouble. If I don't simplify it, I'm looking for angle K. By the way, what do I know about K and J? They're congruent. So K is the same as J, so I don't have to plug it back into both, right? Okay. K is 4y squared, so I'm going to plug it into 4y squared. If I don't simplify it, I have 4 times the square root of 20 squared. What happens? Okay, Lily, so the square and the square root cancel out. So what do I have? 4 times 20, which is 80 degrees. Okay, what if I simplified it and then plugged it in? So 4 times 2 square roots of 5 squared. Say it again. Okay, I need to distribute the square to what, Josh? The 2 and the square root of 5. What most students do is they do this. And it shouldn't be 40, right? Because we just found out that it's 80. So what they make the mistake of is they forget to distribute the square. You've got to distribute the square to both. And so then I have 4 times 2 squared, and the square root cancel times 5. Does that make sense? So 2 is squared and the square root of 5 is squared because they're in parentheses. The whole thing is squared. And I substituted it in, so I have to put it in parentheses. What is 2 squared? 4. What's 4 times 5? And 4 times 20 is 80. So you don't have to simplify it unless it's your final answer. But if it is your final answer, it needs to be simplified. If you do simplify it and plug it in, be very careful with your algebra, okay? Any questions? Awesome. Go to the next one, last example. And by the way, one more time, what theorem did we just use? Third angle theorem. All right, last example. Go ahead, do it on your own. Coming around. If you're having any trouble, let me know. Once you get finished, we need to go back and talk about something that I forgot. When we were working through this example, so stop where you are real quick and look at this example again. Our equation was y squared equals 20. And we took the square root of both sides of the equation and we said y equals the square root of 20. We forgot something. What did we forget? If I said x squared equals 9, what number squared is 9? Is 3 the only number squared that's 9? And what? Negative 3. Do you remember when you were solving quadratic equations in Algebra 1 that you have to put plus or minus? Okay, go back to your notes on this example and add in plus or minus. Here's the thing. A lot of things you learn in algebra are kind of theoretical, solve the equation, and then we get into geometry and we use it, but it applies to a real picture. So now we have to ask ourselves, can y be a positive square root of 20 and a negative square root of 20? That means we got to go back to our picture and make sure that it makes the angle measure positive or it makes the side length positive, because we can't have a negative angle or a negative side length. You can have a negative variable. You can't have a negative angle measure. So if I plug in negative square root of 20, when I plug it in over here in my work, negative square root of 20 squared, what happens? It becomes positive, right? Same thing here. If I have negative 2 square roots of 5, a negative 2 squared becomes positive 4. So whether it's positive square root of 20 or negative square root of 20, both are going to work in the equation, correct? All right. That's important because when we look at the next one, what did you get for your answer for x? For x? X was 4? Okay. Should have been that the angles were equal by third angles theorem, that 2x squared was equal to 4x squared minus 32, subtract 2x squared and add 32, so that you end up with 2x squared equals 32, divide by 2, and x squared is 16. So x is equal to what? X is equal to what? Positive or negative 4. And then we check and make sure that it works for either one. So we plug it in. 4 squared is 8 times 2 is 16. So the answer is sorry, 4 squared is not 8. 4 squared is 16 times 2 is 32 degrees. A negative 4 squared is still going to be positive 16 times 2, which is 32. Here's what's going to happen. Sometimes it's going to give you 2 different answers. So in this case, when you solve, because we're not using quadratic formula, we're not factoring, we get one answer, it's just one's positive and one's negative, right? But just kind of an FYI coming up for Friday. If I were solving an equation by factoring and I ended up with x minus 3 and x minus 2, so that x is equal to what? If I factor it down and this is what I get, what are my answers for x? 3 or 2. Everybody remember that? Add 3, add 2. We have 2 different answers. I could get 2 different answers. And if I plug in 3 to this problem, I'm going to get a different angle measure than when I plug in 2 to that problem. So it could be that you get 2 answers that both work, which means there's 2 different possibilities for the angle measure. And if that's the case, you'll list both of them. Okay? And we're going to review that and talk about that more on Friday. Any questions from today? All right. Your assignment due Friday is core math, page 139, 140, 145, and 146. Textbook page 236, 24, 38, and 44. And textbook page 228, 35 through 37, 44, and 47. And I know it's intense. Some of them are quick. Classify the triangle. Right. Obtuse. Acute. Scalene. It'll go fast. Some of them will take a little bit of work. Okay? But you'll need the practice. Write it down. Due Friday. Your 5 minutes. I promise Friday's assignment will not be perfect.